Hi everybody, this is Shivakumar. Today we are going to discuss about the calorimetry. So what is calorimetry? So whenever we are going to discuss something, first we need to know the meaning of the heading. Then what happens? The name itself gives the idea of the topic, right? So here we are having the calorimetry. So what is calorimetry? So calorimetry is nothing but the study of heat. The study of heat. Study of heat. Study of heat transformation. Heat transformation and to measure of the heat, measurement of the heat, measurement of heat and how it transforms we are going to discuss in this chapter. So the basic definition of the calorimetry is the study of heat transformation and the measurement of the heat, right? So here first we are having the study of heat. So we are going to discuss about the heat. We have to study about the heat. So what is this heat? Yes, so let us write here heat. What is this heat? Right, so heat, so I will give a example. So let us take, so in hot summer you went to a park. There you saw the iron bench and a wood bench. So which one will you prefer to sit? On the metal bench or on wood bench? Yes, obviously you will choose to sit on the bench of the wood. Why? Why? Because there we are going to see the transformation of heat from metal is more than compared to the wood. So for that reason we are going to sit on the bench of the wood, right? So we are having the two benches. First one is metal bench and another one is wood bench. So you would like to sit on the wood bench. Why? Because the transformation of heat is less as compared to the metal bench. So here what happens? Here we are using the heat, right? So heat is the transformation of energy, right? So heat is the transformation of energy. Transformation of energy. Right. So here what happens? Here we are having energy. So from where we got this energy? So this energy is nothing but, heat is nothing but in the form of energy. Heat is in the form of energy. Heat is in the form of energy. In the form of energy. So here what happens? There we are going to observe that the transformation of energy is going to be taken place in the part, right? So the transformation of energy or heat is in the form of energy, right? So let us take two objects. Let us take A and let us take B. Okay? So A and B we are having. So this object is very hot and this object is cold body. So this B is cold body and this A is hot body. So then what happened? So I would like to get contact to these two objects. So then what happens? The heat. So by taking a metal, here I would like to use a metal. Okay. So then what happens? The heat inside of this A is to be transferred to the B, cool body. Right? So here what happens? That temperature difference is there. So it is a hot body and it is a cool body, right? So we are having two types of bodies here, right? So the first one is hot body and a cool body. So here what happened? Here the heat energy is transforming from A to B, right? The heat transformed due to the temperature difference. Heat transformed due to the temperature difference. Okay, DIFF, ERDLC. Right. So here temperature I just wrote TEMP, so it is the short form here we are using. Okay, so here what happens, heat is transformed due to the temperature difference. So what is this temperature? Here we are having the temperature, right? So what is this temperature? So in the first class units and dimensions, first unit here we have studied that in the topic called the units and dimensions, there we have studied the fundamental quantities. So what are the fundamental quantities? We are having 7 fundamental quantities, right? So from there we are having temperature. So temperature is also a fundamental quantity. So let us write the temperature here. Right. So temperature. So what is this temperature? So temperature, it is saying here, right? So first we need to write. What we know we have to write first. Okay. So here we are having the temperature. So temperature is the fundamental quantity. First we need to write that one. Okay. So it is a fundamental quantity. It is a fundamental quantity. Right. Next. Here we got this one. So what is the unit? From there in units and dimensions we have studied that one. So what is the unit of the temperature? So the SI unit of the temperature is about the Kelvin, right? So SI unit of the temperature is the Kelvin, Kelvin. Or we can also take the degree Celsius. Degree Celsius we can also take. And here we know that temperature it is a scalar quantity. It is a scalar quantity. So what is this scalar quantity? So temperature is having the magnitudes, but it does not have the direction, right? But heat, this heat is there, right? So heat is having the direction, where from heat is always transformed from hot body to cool body. So I would like to write here, heat transfers from hot body to cold body, right? So heat always transfers from hot body to cold body, but not heat transfers from cold body to hot body. It is wrong, the false statement, right? Okay, so heat is transferred from hot body to the cold body. Okay, next here we are having the temperature. So temperature is a scalar quantity, right? It has the magnitude, but it does not have the direction. Okay, next we will see. So what is this temperature? What is this temperature? So temperature is nothing but the measurement of the degree of the hotness or coldness of the body, right? So I would like to write the definition of the temperature is the measurement degree of hotness or coldness of the body. Right, so the measurement of the hotness or coldness of the body, there we are going to see the temperature. So here you see, here we are having the hot body and here we are having the cool body, right? So if let us say this hot body about the 20 degrees Celsius and this cold body I would like to take about the 3 degrees Celsius, right? So here what happens, here this 3 degrees and this 20 degrees are the temperatures of these bodies. Okay, so 20 degrees is the temperature of the A and 3 degrees is the temperature of the B. Okay, so here what I mean, here the temperature is measurement of degree of hotness or coldness of the body. Okay, right. Next we'll see. So from where we got this temperature? So this temperature is got from the zeroth law of the thermodynamics. Zeroth law of thermodynamics. So thermodynamics, in that we are going to discuss about the first law, second law, zeroth laws of the thermodynamics. Then we are going to study in the future. Okay, in next class. Okay, and next year we are having the zeroth law. So what is this zeroth law? So let us say here we are having a object, a body A, and another body B. We are having two bodies. These two are the thermally equilibrium to each other. A and B are thermally equilibrium. So what is thermally equilibrium means? The temperature what is having inside of this A, not inside, on A and B are equal to each other. Right? If the temperature of A, if the A and B are thermally equilibrium, if A and B are thermally equilibrium, then if A and B are thermally equilibrium and B and C also thermally equilibrium. If A and B are thermally equilibrium, B and C are also thermally equilibrium, then A and C also thermally equilibrium. A and C are also equilibrium, thermally equilibrium. Okay, so let us take an example of this. So let us take A and B are good friends. B and C are also good friends. So A and C are also good friends. Okay, it is not necessary to have A and C to be a good friends, but we need to consider like that. Okay, so A and B are the good friends and B and C are also the good friends. Then A automatically good friend to the C. Okay, think like that, but not exactly to be how the A has to be good friend of C. Okay, next we will see. So here we have discussed about the temperature. It is a fundamental quantity, and the SI unit of the temperature is Kelvin or degree Celsius, and it is a scalar quantity, and the measurement. It is the measurement of the degree of hotness or coldness of the body, and it is derived from the zeroth law of thermodynamics. Okay, now let's achieve the highest temperature and the lowest temperature. In laboratory, we have achieved the highest temperature and the lowest temperature. So the highest temperature is about the 10 to the power 8 Kelvin, and the lowest temperature is about the 10 to the power minus 8 Kelvin. So in laboratory we have achieved this, right? So the highest is the 10 to the power 8 Kelvin, and the lowest temperature is 10 to the power minus 8 Kelvins. Okay, right. So we know that the normal human temperature So normal human temperature is about the 37 degrees of Celsius. 37 degrees of Celsius, and it is also equals to 98.6 degrees of Fahrenheit, and it is also equals to 310.15 Kelvin. So here we are having the normal human temperature about the 37 degrees Celsius and 98.6 degrees of Fahrenheit and 310.15 Kelvin. So here we are having the measurement is the temperature measurement in degrees Celsius, and here we are having the Fahrenheit, and here we are having the Kelvins, right? So we'll see later about this, and just we'll talk about the what we call the temperatures below or above the 0 Kelvin, and what we call the measurement of the temperature is above very high. Okay, so they are called the cryogenics. First one we'll write cryogenics. So what is this cryogenics? So cryogenics is that the measurement of the temperature about 0 Kelvin. About 0 Kelvin. Okay, this is not okay, this is 0 Kelvin. Okay, and next we will see pyrometry. So pyrometry is that the measurement of the temperatures are very high. So measurement of measurement of temperatures, very high. Okay, so pyrometry means the measurement of the temperatures are very high, and the cryogenics is that the measurement of the temperatures about the 0 Kelvin. Here I am using the Kelvin, right? So let us see the triple point of water. So what is the triple point of the water? Triple point of water. Right. So what is this triple point? What is triple? Triple means what? 3, right? So triple point of water. So let us say that we are having 3 states: solids, liquids, and gaseous. Solids, liquids, and gaseous. Right. So for water we are having ice, water, and the vapor. Right? Ice, water, and vapor. So we are going to have water and ice and the vapor at a particular temperature. That temperature is called triple point of the water. That is about 0.01 degree Celsius. 0.01 degree Celsius. So at 0.01 degree Celsius is called the triple point of the water. Triple point of the water. There we are going to see the ice, water and vapor. Ice, water and vapor. So at this temperature 0.01 degree Celsius we are going to observe the ice, water and vapor at that point. That is called the triple point of the water. Right. So I would like to ask you one question. So here we are having A and B, right? So here this is having the temperature T1 and this is having the temperature T2. So T1 is greater than T2. So here what happens? Here we just kept a metal. Let us assume a metal is contacted between these two. So then what happens? The temperature of A is to be transformed to B. Temperature A is transformed to B. No. Heat is transformed. Here we need to use the heat. Heat is transformed from A to B. Temperature is changes. Right? Are you getting? So temperature of A is high compared to the B. Right? So heat of A is transformed. Here we need to use heat is transforming. Temperature is changing. That is what we need to think. That is what we need to see. So temperature is increasing or decreasing. Okay, and the heat is transforming. Heat always transfers from hot body to cool body. Right? So let us see. Here we are having degree Celsius, Fahrenheit Celsius, Fahrenheit and Kelvin. So we will discuss about these three. Okay. So here in degree Celsius. So degree Celsius is represented like this. Okay. So degree Celsius, the melting point. We need to take the melting point and the boiling point. So let us write about the first one. Here we write the melting point and boiling point. So let us take for degree Celsius. So for degree Celsius, here the melting point, let us take ice. Ice is to be melt into the water, right? So for degree Celsius, that is about 0 degrees Celsius. And the boiling point means what? The water has to be evaporate. Right, that means what happens? That is, the water has to be changed its state. So water to vapor we need to convert. So here what happens? Melting point, in that what happens? The ice is converting into water. The change of state is taking place here, right? So the change of the state is taking place at the melting point. Here what happens? Ice is converting to water. Right, and in boiling point, here we are going to see the water is changing its state to the vapor. Right? Okay. So here we are having the melting point that is equals to 0 degrees Celsius. and the boiling point that is equals to 100 degrees Celsius and degrees of Fahrenheit. So degrees of Fahrenheit, there we are going to observe that the melting point of ice. So the melting point of ice is about the 32 degrees of Fahrenheit. 32 degrees of Fahrenheit and the 312 degree, sorry, 212 degrees of Fahrenheit is the melting point of the boiling point of the water. And let us see the Kelvin. So Kelvin, the melting point of ice is about that 217. That is 273.15 Kelvin, and this will be the boiling point will be equals to 373.16 Kelvin. So here triple point of water is also, you can also write that 273.16 Kelvin. You can also write this 273.16 Kelvin. Okay, right. So here we are having the boiling point and the melting point of water we have seen. Okay, so how do we convert? How do we convert into degree Celsius into Fahrenheit, Fahrenheit into Kelvin? How do we convert? So let us take the required temperature. So required temperature, RT I am taking required temperature minus melting point by required temperature minus melting point by boiling point minus melting point. Boiling point minus melting point. So this is the constant for all the measurements. Okay, so here we'll see for the degree Celsius first one. Okay, so let us take the unknown quantity about the degrees. I want it in the degree Celsius. Let us take x degree Celsius minus, let us write that in. So let us take x degree Celsius. Okay, minus melting point. What is melting point? Melting point is 0 degree Celsius. Let us take 0 here. Okay, by here the boiling point minus melting point. So 100 minus 0. 100 minus 0 is 100, right? Let us write 100 minus 0. So that will be equals to x degree Celsius by 100. Right? Let us take this Fahrenheit degrees. Okay. So Fahrenheit degrees is how much? Let us take an unknown quantity about the temperature of the Fahrenheit, that will be equals to, let us take y degrees of Fahrenheit. Y degrees of Fahrenheit minus, what is melting point? 32 by boiling point minus melting point. So 212 minus 32, that will be equals to 180. Okay, and this also will be equals to, here we are having that the Kelvin minus the melting point. Melting point is 273.15. Let us write here 273.15. You can write up, you can also write up your wish. Okay, so here the difference in the melting point and the boiling point is about the 100. Okay, so here these all depends, all these are the constants. So x degrees of Celsius by 100 is equals to y degrees of Fahrenheit minus 32 by 180 is equals to k minus 273.15 by 100 is equals to the constant. So we can change this into, we can change the Celsius degrees into Fahrenheit by using this. Okay, so I would like to write it again. So x degrees, let us write the c degrees, right? Let us write. So c degrees by 100 is equals to f minus 32 by 180. In the case of y, I am taking f. Okay, and here k minus 273.15 by 100. So by using this relation, we can find out the temperatures in the different forms of degrees. So let us do one question. How do we convert degree Celsius into Fahrenheit, and how do we convert degree Celsius into the Kelvin. Okay, let us say we have already having the relation, right? So relation is C by 100 is equals to F minus 32 by 180, that will be equals to Kelvin minus 273.15 by 100. So here we have already discussed that the normal human temperature will be equals to 37 degrees Celsius, right? So 37 degrees Celsius. This also will be equals to 98.6 degrees of Fahrenheit. This also will be equals to 310.15 Kelvin, right? So we'll find out these values. Okay, so let us take 37 degrees. So 37 degrees into the Fahrenheit we need to convert. So how do we convert? So let us take the C by 100. So here we are having the C value will be equals to 37. So 37 by 100 will be equals to F minus 32 by 180. Right? So this 0 will get cancelled out and this will be 5, 9. So take this 9 from this side to this side. So 9 by 5 into 37 is equals to F minus 32. Right? So here what happens? This value will be equals to 5 ones, 5 sevens, and here we are going to get that 4, and we are going to get this one 66.6 is equals to F minus 32. So take this from RHS to LHS, then we are going to get that 66.6 plus 32 is equals to Fahrenheit, that will be equals to 96.8 degrees of Fahrenheit we got. Okay. So let us take 37 degrees into the Kelvin. So here we are having that the relation of C by 100 is equals to constant. K minus 273.15 by 100 is constant. So for that reason we need to take this. So C here we are having 37 degrees, right? So 37 by 100 is equals to K minus 273.15 by 100. So this 100 will get cancelled out. So K value will be equals to, let us transpose this 273.15 from RHS to LHS. Then we are going to get that 273.15 plus 37, that will be equals to 310.15 Kelvin. Okay. So here we find out that 37 degrees Celsius is equals to 98.6 degrees of Fahrenheit, that will be equals to 310.15 Kelvin. Okay. So like that we can convert the temperatures. Right. Now we'll see calorie. So what is calorie? So calorie. So we are discussing the calorimetry, right? So here we are having the calorie. What is calorie? Calorie is nothing but the energy required to rise the temperature of 1 degree Celsius of 1 gram of water. 1 gram of water is called the calorie. So here what happens? Here calorie is also the unit of energy. So it is a unit of energy. So it is defined as the energy required to rise the temperature by 1 degree Celsius of 1 gram of water. Okay. So defined as energy required to rise the temperature by 1 unit, that is equal to 1 degree Celsius, of 1 gram of water. 1 gram of water is called the calorie. Right? So here we are having the energy. So here in heat we are going to discuss about the energy means here heat energy. We need to understand that is heat energy. So how much heat energy is required for 1 gram of water to rise the temperature by 1 degree Celsius is called the calorie. Right? So calorie is the unit of the energy. Okay. So 1 calorie. So calorie is equal to CAL. 1 calorie is equals to 4.2 joules per gram degree Celsius. So 1 calorie is equals to 4.2 joules per gram degree Celsius. So let us write 1 calorie is equals to 4200 joule kg degree Celsius. So here we are having the kgs and here we are having the grams, right? So 1 calorie is equals to 4200 joules per kg Kelvin. Kg degree Celsius. We'll see the specific heat capacity. Specific heat capacity. Specific heat capacity. So, in calorie we have seen that it is the energy required to rise the temperature of 1 degree Celsius of 1 gram of water we have used in 1 calorie, right? So, in specific heat capacity, there we are going to use, it is the energy required to rise the temperature of 1 degree Celsius of 1 gram of the substance. Here I am using the substance, and in the calorie we have used the water, right? So here I am using that the specific heat capacity is the energy required to rise the temperature by 1 degree Celsius of 1 gram of substance. Here I am using the substance. 1 gram of the substance is called specific heat capacity. Specific heat capacity of the substance. Right? So here specific heat capacity is the energy required, the amount of energy required to rise the 1 degree Celsius of 1 gram of the substance is called the specific heat capacity of the substance. So here heat is having Q, right? So heat required. So here we are using the grams, right? So we are using the mass, and S is my specific heat capacity and the temperature delta T, right? So here S will be equals to Q by M delta T. Q is energy, M is the mass, delta T is the change in temperature. So here what happens? S is not only for 1 degree Celsius, it is the minimum energy. It is the minimum energy required to rise the 1 degree Celsius of 1 gram of the substance, right? So we can also take the more substance. That means more. If we want the more than 1 degree Celsius, then we need to use this formula. So here what happens? Here Q is energy. So energy unit is joules per mass is kg. And delta T is, you can also take the degree Celsius or Kelvin. Okay, so mostly we will take the degree Celsius here, right? Okay, so we have seen that the specific heat capacity of water is 1 calorie, right? So 1 calorie. Okay, so that will be equals to 4.2 joules gram degree Celsius. That is also equals to, we have seen that 4200 joules kg degree Celsius, right? And you see the specific heat of ice and the specific heat of water, specific heat of vapor. The specific heat of vapor will be equals to 1/2 of calorie. 1/2 of calorie. That will be equals to 2.1 joules gram degree Celsius or 2100 joules per kg degree Celsius. So vapor. So the specific heat of ice will be equals to 1/2 of calorie. 1/2 calorie. So that is half calorie. So here for water we are having 1 calorie. and for the specific heat of ice and vapor will be equals to 1 by 2 calorie, that will be equals to 2.1 joules per gram degree Celsius, or 2100 joules per kg degree Celsius. Okay, right, let us do one question. Okay, so a container is having 2 kgs of water. Okay, so container is having the 2 kgs of water, 2 kg of water. Initially it is having the 10 degree Celsius. 10 degree Celsius. What is the energy required to rise it to the 20 degree Celsius? So 20 degree Celsius. So what is the energy required? So we know that the specific heat capacity of the water will be equals to 1 calorie. That will be equals to 4.2 joules. Here we are having the kgs, right? So for that reason, first we need to take joules. So for that reason, first we need to take 1 calorie will be equals to 4200 joules per kg degree Celsius. So initially we are having the temperature, initial will be equals to 10 degree Celsius. So here we want that temperature to be 20 degree Celsius. So how much energy we want? So we know that Q is equals to ms delta T. So here we are having the T final and T initial. So what is the delta T? That is change in the temperature. 20 minus 10, that will be equals to 10. Okay, right. So the mass, what is the mass here? Mass here we are having the 2 kg. So 2 kg specific heat capacity of water, that will be equals to 4200 joules per kg degree Celsius. Joules per kg degree Celsius. So we need to write here 4200. And next temperature. So temperature, change in temperature, that will be equals to 20 minus 10, that is equals to 10. So here we are going to get that 8.4 into 10 to the power, here we are having that one, right? So 1, 2, 3, 4, right? So 10 to the power 4 joules. So the energy required, here this is Q. Okay, Q means heat energy. The energy required for 2 kg of water initially at the 10 degrees to require it to the energy required to get the 20 degrees Celsius, we need to have 8.1 into 10 to the power 4 joules of energy. Okay.